Welcome to a new video lecture. Today we will discuss a problem related with when a train of continental loads traveling across a beam. So please note down the question. A train of load shown in figure is crossing a simply supported beam of span 40 meters. Calculate the maximum shear force at a section 15 meters from the left support. Okay. So those who didn't watch the previous lecture, please go and watch the video lecture. Okay. So in the question it is given that a simply supported beam with its total span length is 40 meters and a train of continental load, already we discussed the term train of continental load, a series of continental load is traveling. So it is also arranged in this format, the 4 kilonewton in front and the behind one is 10, then again 10, then 6 and again 6. So 5 total loads. So 5 loads are traveling in a series format with a span difference 2.5, 3, then 3, 2.5 respectively. Okay, between each load the span distance is also given 2.5, 3, 3 and 3, 2.5. We have to find the shear force, maximum shear force at the point C. Okay, so if we arrange the loads in this format, that means this 4 kilonewton is touching at this point, that is here shown here, we will get the negative shear force. So here Z by L gives minus 15 by 40, so minus 0.375. Okay, so before going to, we have to finalize that whether this loading condition is right or not. For that we will apply our formula. Already we mentioned this formula in the previous lecture. Minus WA by L plus W1. What do you mean by this capital W? Capital W means you have to sum up all these loads. That is 6 plus 6 12 plus 20. That is 12 plus 20 32 plus 4. 36. So 36 our capital W. Then this A. A means if this load, let us assume this 4 kilonewton as W1 is crosses this C and at the point C 10 kilonewton, that is W2. Let us assume W2 is standing at the point C. So this distance will be our A, that is given as 2.5 by 40. Plus 4 means this one. Okay, here we are getting that 1.75 means it is a positive value. So if it is a positive value means it will again reduce the shear force value. So we can ignore this situation. This won't happen. This will give the maximum negative shear force value. Okay. So then now we will calculate each ordinate, what is the ordinate here, what is the ordinate here, what is the ordinate here, and multiplying with each loads, and finally we will calculate the maximum negative shear force value. Okay. So this is the condition. This condition is right. We already proved that. So we can apply the similar triangle law and find out the each value y1, y2, y3 and y4. y1 will be in this format. 0.375 means this ordinate distance is 0.375 by 50. This much distance, support to the C point 50 multiplied by 15. This much distance 50 minus this 2.5. If you subtract this 2.5, you will get the remaining distance. So you can easily find out the value of y1. Similarly, you can find out y2, y3 and y4 and apply in this equation. You will finally get the shear force, negative shear force will be minus 0.375 multiplied by 4, that is the load acting here, minus 10. That is, next we are going to consider the first case, that is y1. It will be equal to 0.375 by 50 multiplied by 15 minus 2.5, already we determined. And for easiness, we are here itself, we are mentioning this y2. Again, we are going to third load. This is W2, this is W3. minus 10 multiplied by 0.375 by 15. This much term will be common everywhere. Multiplied by 15 minus, you have to subtract this much distance, this triangle you have to consider. So 15 minus 2.5 plus 3. Okay, so this is also over. After that, you have to consider W4, that is minus 6 multiplied by 0.375 by 15. 15 minus 2.5 plus 3 plus 3. Again, here also 3. That is also over. And if you, here again minus 6 multiplied by the fifth load we are considering. So 0.375 by 15 multiplied by 15 minus 0.25 plus 3 plus 3 plus 2.5. All the distances to be on this small triangle you have to take. And finally you will get minus 8.575 kilonewton. That is the maximum negative shear force. Then our intention is to find out the maximum positive shear force value. For that, you have to arrange that means the last load to be placed over the point C, and it will be placed accordingly. This distance is 2.5, and accordingly you will place and find out each ordinates also y1, y2, y3 and y4. So y1 will be 0.625. This maximum value we already calculated from here. So 0.625 by 25, this much distance 25. Then you have to consider 25 minus 2.5, you will get the y1 value. And similarly, you can substitute y2, y3 and y4 also. Okay. So if you substitute the values respectively, here all the values are positive, here all the values are positive, you can directly substitute. 0.625 multiplied by 6, first you are going to consider this 6 load. So 6 multiplied by, directly you will get. Then 6 multiplied by this y1 ordinate, then 10 multiplied by this y2 ordinate, then again 10 multiplied by y3 ordinate, then again last load, that is fourth load is acting for 0.625 by 25. Again you will get the final 17.525 kilonewton. That is the arrangement is right or not. That also you have to check out. So for checking out whether this arrangement is right or not, you can check in this format: WA by L minus WN. This is the equation for checking whether the arrangement of loading will get the maximum positive shear force value. So here this W means the total load, that is 6 plus 6 plus 10 plus 10 plus 4, that is already mentioned here also. Then this A represents here if the point C, if W4 is acting, that means this 6 kilonewton is acting at the point C and this W5 is behind. If this is the situation, then the A represents this distance between this W5 and W4, that is 2.5 in this case. And the last one, the number 5, or here it represents 6. So you can write down as, and you will finally get minus 3.75 if you substitute. So here it means that we have to ignore this situation also. This also should not happen, because here the value is again going to be decreased. Okay, negative sign indicates that here the maximum positive value is going to decrease. So already we got the value of 17.525. So if you consider this situation, the value will again reduce. So our final result will be 17.525 and the arrangement will be in this format. Okay, so finding out the maximum negative shear force, we will follow this format, and for finding out the maximum positive shear force, this condition you can follow, or either you can follow the trial and error method also. Okay, so with this we will wind up today's section. Thank you all.